Thank you for choosing to view our demo on software deployments for the enterprise. I'm Tracy Reagan, and Steve Taylor, our CTO of OpenMake Software, will be doing the demo for us. So today we're going to be talking about the software deployment for the enterprise or for large customers. Many of our large customers ask us about the ability to support multiple teams using multiple repositories and deploying to multiple platforms. This is a common requirement for the enterprise where you may have development teams writing software for Linux, Unix, Windows, and ZOS, and the central release teams would like to use a single tool to deploy to all of those different platforms, pulling from the different repositories. So in many cases, each team defines what repository they would like to use for their binary repository or their version control, which means that an enterprise could have Subversion, Git, Harvest, IBM RTC, and even Endevor as potential locations where source code or binaries may reside, and you need to be able to build and deploy from those different repositories to different platforms. It's also not uncommon for a single application running in a single platform to come from different repositories. So different components might be stored in Subversion, others might be stored in IBM RTC or Endevor, or come from an external repository such as a Maven repository or Archivia. So we're going to look at two solutions today to solve this problem. The first being Meister. This demo will cover the ability to compile the code without using scripts. So Meister, it manages the automatic compilation for multiple languages on multiple platforms, including the Mainframe, the ZOS platform. And it does this compilation process using what we call build services, which are like playbooks, if you're familiar with the distributed platform sort of model or model-driven processes, or a processor if you're more familiar with the mainframe. These basically are replacements of one-off scripts. The scripts are often the brittle part of the process, and they're often developed in Maven, Ant, or Make. We're going to do this without having to have those one-off build scripts, or deploy scripts for that matter. So Meister can pull source code from any repository, compile it, and store it back into the repository of your choosing. It also includes its own CI server, or it can integrate with Jenkins. Now, if you're a large environment, you might need the services of server pooling and load balancing that Meister can offer, and we can support up to 10,000 builds per day in our testing and our customer feedback. So Release Engineer is the second solution we're going to look at, and Release Engineer is an application and release automation solution that manages the automatic deployment of binaries to multiple platforms, and yes, it does that for mid-range and ZOS. It does the deployments using activities, again like a processor on the mainframe or a playbook in Ansible terms, and it does it without using the one-off scripts written in things like Python or Ruby. It can pull the binaries from any repository, package them up into what we call components. Multiple components make up an application, and multiple applications make up a release. It can also manage server configurations, deploy the binaries with roll forward and rollback support. It can also do version jumping, so if you want to jump from a 1.1 to a 1.5, you can do that. And it also integrates, like Meister, with Jenkins or Bamboo for your CI processing, or Meister itself. And it can that process can be further managed through our tightly managed calendaring system. So the calendaring system can help the central release teams control how many times a CI process executes by saying, sorry, we're not available at this time, and not having to have somebody actually be a gateway for that. And the best part is it requires no agents. So we're going to wow you today. We're going to do a demo that takes a piece of code from IBM RTC, a piece of code from Harvest, and a piece of code from Endevor. We're going to compile them all separately and create 3 different application packages, and we're going to deploy each of those application packages to IBM WebSphere. We're then going to take all 3 of those applications and create what we call a release and deploy them all at once. We're also going to show you a rollback to the version n.1, n-1. So how that's going to look, we're going to first take Meister and we're going to pull code from those different repositories. We're going to compile it and we're going to store the binaries back into those different repositories. So we're going to store the binaries in Harvest, RTC, and Endevor. Once that's done, we're going to ask Release Engineer to pull those binaries from those different repositories and send them out to IBM WebSphere. So let's see it live. I want to present Steve Taylor, who will be doing our demo for us.
Hello everybody. Today we're going to deploy 3 different applications from 3 different source code repositories and binary repositories. So the application that we're going to deploy, there's going to be one coming from Harvest, which is version 1 that we have set up right now. We're going to deploy from Endevor, which is also set at version 1. And finally, we have Rational Team Concert, which is version 1. So let's go ahead and go over to Harvest. And we're actually going to make a source code change. So I'm in Eclipse here. I'm going to make my change. Commit it. Now I have my source code change into the Harvest repository. I'm actually going to go over to Harvest, and you can see right now we have version 18 of our WAR file. I'm going to go ahead and build from inside of Harvest using Meister. Let me clear this. And we'll see that the workflow monitor is going to get refreshed here. And this is Harvest triggering the Meister build. And one of the steps that we have is to actually publish the WAR file back into Harvest. So our workflow is done. You can see we have version number 19. Now we're going to go ahead and execute Release Engineer from Harvest as well. So I've triggered the deployment of our WAR file from Harvest using Release Engineer. So if we go over to Release Engineer here, when we look at our Harvest version 2, our timeline, you can see that we deployed it less than a minute ago. The files that we checked out came from the Harvest repository, and they're being deployed out to our WebSphere server. So let me refresh this, which is our detail log. And we can see our Harvest definition has been installed successfully. So if we go to our Harvest web page and hit refresh, we have version 2. So to recap, what we've done is we've checked into our source code change into Harvest. From Harvest, we've triggered a Meister build. The Meister build pulled the source code from Harvest, compiled it, and pushed the resulting binary back into Harvest. Next, we went and executed a Release Engineer deployment from inside of Harvest. The Release Engineer deployment pulled the WAR file from Harvest and deployed it out to our WebSphere server. Next, let's go ahead and do the same change for Endevor. So I'm going to make our source code change. So we've changed version 1 to version 2. And I have a quick check-in script that's going to check in the source code into Endevor. What that check-in script does is it packages together the Java files and places them as a member in our source code directory, our library, I mean. So we have an updated member here, which is an archive of our source code. Okay, now I've gone over to the Meister ISPF panels for the mainframe, and we're going to look at our definition for our WAR file. So just like we have on the distribute side, we have target definition files. And if we edit this one, we can see that we're going to create a member in the WAR library, and we're going to pull two source code dependencies. The first one is coming from the source library, which are source code changes that we just made through our VI session. And our second one is web files such as HTML, GIF files, CSS, those types of other web content files that are needed for the WAR file. So those are our two dependencies that Meister is going to use in building our WAR file. So let me go ahead and hit build. So we have our first two steps. And just like we have on the distribute side, we have the build, make, and OM step. So build, make is taking our snapshot of our TGT and knowledge base server and creating our build control file, which is then utilized by OM that is going to actually do the heavy lifting and compile and archive our WAR file. So OM ended up submitting another step, which is going to be the actual compile step. In here we did the compile and created the WAR file. So you can see where we've added in our web content as well as our new classes. That WAR file was placed into our dev stage of the life cycle. So this is our WAR file here that we'll now use as input to release engineer for us to do the deployment. So let me go over to release engineer. We'll deploy Endevor version 2. You can see we pulled our WAR file from the Endevor staging. And if you look at the detail, we're executing WebSphere to deploy the WAR file. So we've installed our application out to WebSphere. Give it a moment here, and we'll go ahead and refresh our website. So we have version 2 now of our application. So to recap for this deployment, what we did was we made a source code change on USS to our Java code using VI. You can use any editor that you want, but I just chose VI. I then checked in that source code change into Endevor. From there, I executed a Meister build on ZOS using the Meister for ZOS. That process pulled the source code from Endevor, compiled it, and pushed back the resulting binary back into Endevor. So we have our WAR file, our new WAR file in Endevor. Then release engineer was triggered to go ahead and deploy from Endevor the WAR file out to WebSphere. We're going to do this now for Rational Team Concert. We're going to make our source code change. We're going to deliver that. So now I have our source code change checked into Rational Team Concert. From inside of Team Concert, I'm going to trigger a Meister build. And you can see our new workflow has been triggered. So this workflow is pulling the source code from Team Concert, compiling it, and pushing the resulting binaries back to Team Concert. So we go over to our builds. Our build is complete. We can see the Meister log from inside of Team Concert. So here's the Meister log. Also, we have our artifact, our binary, that's been attached to this build. So, like I said, Meister uploaded or published the WAR file to Team Concert. Now we're going to go ahead and deploy using Release Engineer from Team Concert. Again, we'll request our build. And we'll be able to go over to Release Engineer and look at our timeline. So you can see we pulled from RTC and we're pushing that out to WebSphere. Just wait for the application to restart. And if we go over to our website, we have version 2 of Team Concert. So to recap, we made the change to the source code, checked it into Team Concert, then we requested a Meister build from Team Concert. Meister went out and pulled the source code from Team Concert, compiled it, created a new WAR file, and check that WAR file back into Team Concert. Then we went and requested a deployment through Release Engineer using Team Concert. That deployment pulled the WAR file from the Team Concert binary repository and pushed that out to our WebSphere server. So now we have version 2 on all of our applications. We're going to go ahead and roll those back. So let me go ahead and deploy the -1 version from Endevor. So this is going to go out to Endevor and grab the -1 version and deploy that out to our WebSphere server. So we're doing a rollback here. You can see we went out to our Endevor staging area and pulled the -1. Our deployment is almost complete. And if we go to Endevor, we have version 1. Now let's go ahead and put Harvest out as version 1. So again, this is going out to the Harvest and grabbing the -1 version of our application and deploying that. So here we have our -1 version. And we're at version 1 here. Finally, we're going to do Team Concert. Deploy that out to our WebSphere server. So again, we're going out to Team Concert, pulling the -1 version from Team Concert and redeploying that. As part of the rollback and roll forward functionality of Release Engineer, you can pick and choose any point, any version that you want to be on your servers. And Release Engineer will figure out through the definitions the individual steps, the incremental steps to get you from one version to the next version. So in the case of database changes, those are typically incremental changes, alters and adding of data and removing of data. Those are done in incremental fashion, and Release Engineer understands how to roll forward and roll back those incremental changes no matter which version you choose to place as part of your deployment. So let's look at our deployment. So we have our artifacts, look at our log, and we've completed this. So we have version 1 out here. So next we're going to build up a release. So a release is made up of applications, and applications are made up of components. So in this case, I have release version 2, which is made up of the version 2 of each one of our applications. I'm going to go ahead and deploy this release. And when I deploy this, we're actually going to deploy the Harvest version 2 application. Once that's completed, we're going to do the RTC version 2, and then followed up by Endevor. You can parallelize the parts that can be done in parallel just by how you lay out your graph here on what applications are dependent upon other applications. So let's go over to our timeline. And then we'll just go down and see if the Endevor one is completed. So now we're starting the Endevor application deployment. So within this release, gives you the capability to package together individual applications that need to be on the same release schedule and are dependent upon each other. So let's go over to our website. So here's Harvest. So we'll be at version 2 now of Harvest. Endevor. We're at version 2 for Endevor. And then finally Team Concert. We're out at version 2 for Team Concert. Just like you can roll forward at the release level applications, you can also roll back. So I'm actually going to deploy version 1 or roll back to version 1 for all of our applications. So you can see we have version 1 for Harvest, Team Concert, and Endevor. So we're going to roll back at the release level all the different application versions. Okay, so if we refresh, we're at version 1 for Harvest. Look at Team Concert, we're at version 1 there, and Endevor, we're at version 1 there. So to recap, we're able to package together applications into a release. We can roll forward that release or deploy that release. And then also we can package together and roll back those applications at a release level. So you have the capability to do that forward and backwards, making it very easy to roll forward or roll back a release. Today we just touched on the highlights of interacting with Harvest, Endevor, and Rational Team Concert and doing deployments from those different repositories where we're compiling the source code with Meister, pushing back the resulting binaries into corresponding SCM tools, and then deploying with Release Engineer out to our WebSphere server, pulling from those different SCM tools. There's so many more things that we have inside of Release Engineer and Meister that look for our other demos out on our website for further details on the capabilities of both Meister and release engineer. Thank you very much.
Thank you so much, Steve, for that fabulous demo, and I told you we were going to wow you. So a little bit about how to obtain Meister and Release Engineer. These two products are sold separately. We offer an easy entry pricing program. It's free to the team level, which means you can have a fully functional product of both Meister and Release Engineer, supports 2 applications with unlimited seats and unlimited version releases. Once you pass those first 2 applications, it's $1,000 per application, and the support for it is $250 per year. You can download both Meister and Release Engineer from GitHub. You can go to our organization, OpenMake-software, and go to the Release Engineer or Meister repositories and releases to pull that code down. You can also contribute back any reusable playbooks that you might add to the GitHub repository to share with the general community. Or you can also go to openmakesoftware.com. Thank you very much for taking the time today to see our multi-platform, multi-repository software deployment.